Hello, my name is Kyle Carter. I am in ECEN 218. This is Lab 4. The different relationships between the K-maps, truth table, schematic, and the waveful diagram. And this one can be seen by looking at the data findings. You can see that the outputs are related to the K-maps by looking at the truth table. The first potential output with it, which is 0000 input, which has an output of 10000000, and the last possible input is 1111, which has an output of 0001110. The results from each one is shown in the K-maps. You can observe that the truth table inputs and the outputs line up with the development area inputs and outputs when your development board is functioning. You can observe how the K-maps correspond to the table inputs by looking at them, and the node attributes to Ling, Pence, and logic gates was a benefit during this lab. Here I have my DE10 light board. Right now it is displaying 0100. Next it will display 1010. Then it will display 1001. Then it will display 1111. Then it will display 0011. And that's enough. Okay. So for this lab, we used the different pins that were off for, let me see if I have that one up here. No. Okay, so there were, and we used a different variety of different gates, such as like AND gates. I used the 2 input AND gates, 3 input AND gates, 3 input OR gates, 4 input OR gates, as well as 2 input AND gates, and that described the values based off of the schematic, based off of the diagram that I was given through my K-map. The modifications during the lab that you would have considered. If I was asked to display a hexadecimal equivalent of binary input range of 00000 through 11111, I would then have to do a 5 input due to the fact that for that one it would be on the 8-bit binary input range. So I would have to use the 8-bit section as opposed to the 4-bit for this current lab that we're doing. So I'll have to use the 8-bit. So that would be 2 to the 5th. So that would be 32 as opposed to 16. And that's what I would do for if I had to do 5 inputs as opposed to 4. Because for this one we just had to do 16 because 2 to the 4 is going to be 16 and 2 to the 5th would be 32. So I'll have to do 5 inputs, and then that would be different. Change the whole lab. You continue with the lab by using your pin planner to assign the inputs and the outputs to the proper locations on the DE10 lights development board, and you see if there were any problems associated with that. And the inputs are linked to any of the board's 4 switches that are on the right hand side, and while the inputs are connected to the board 7 signal display, then that's when they will light up. Thank you.